Hi guys, welcome back to Stats. This is Mr. Robeson here. This is the last section in 3.1, our introduction to normal curves. We're going to take a look at standard normal curves, and we're going to learn how to find probabilities using normal curves two different ways, using a table and using the calculator. All right, we're probably going to always use the calculator, but I just wanted to show you the table because it's kind of a neat thing. All right, so our standard normal curve. So we've got our empirical rule. It's nice, but it only works if we know things are exactly 1, 2, or 3 standard deviations away from the mean. If we don't have things that are exactly 1, 2, or 3 standard deviations away from the mean, we need to do something else. All right, so this is where they had the idea to come up with this standardized normal curve. And if you hear the word standardized, hopefully you think of standardized scores or z-scores. So we standardize everything using z-scores, which means we have a normal distribution with a mean of 0 and a standard deviation of 1. All right, so we can take this normal distribution over here. I don't know what this is, but the mean was 110, and it looks like the standard deviation was, if we just subtract between those two, it was 20. All right, so if we take this and just switch everything over to z-scores, we end up with this standardized normal curve with 0 in the middle, -1, -2, -3. This stands for the number of standard deviations. So these are z-scores across the bottom here. Over here, these were x values for just some sort of distribution. All right, so now this is the number of standard deviations away from the mean for everything. And what happened many years ago is some mathematicians got together and they figured out what the area is of every little part of this graph. Because there is some sort of equation or function that models this curve here. It involves E and it involves integrals for those of you that are in calculus. All right, so there is a little calculus involved to find the area under this curve. Right, so what they did is they took all that information and they put it into these tables. So they made tables based on whatever your z-score is, and they always found the area to the left. So here's your z-score. This is the area to the left or below it. So this is the area left of that z-score, or we can say below that z-score. If we want to find the area to the right, remember the whole area is 1, so this is 1 minus the area to the left. So we find the area to the left, and we do 1 minus that to find the area to the right. All right, so let's see how this chart works. So we want to find the area left of z equals 1.12. All right, well, we'd have some sort of graph. I'm just going to draw a little small one here. 0 is going to be in the middle. 1.12 is going to be somewhere up here. And we want to find this area over here. All right, on the AP exam, if we're working with z-scores and they ask you to find an area, you should be drawing a graph. All right, so we go to our chart and we look for 1.12. Well, on one side it has the first 2 digits. On the other side it has the third digit. So we look for 1.1. So here's 1.1 all the way down at the bottom. And then we go over to where we have 0.02, so ending in 2. And then this is the number that's where they meet. So that means that this area is 0.8686. That's how the chart works. All right, real straightforward, really easy. We just find where do these two meet, and that is going to be our answer. That's our area to the left. All right, so we got another one, area to the left of 0.34. All right, so let me switch colors here so we don't get mixed up. So I'm going to draw my little normal curve. It's not perfect, but you know what it'll do? 0.3 is going to be pretty close. 0.34, pretty close to the mean, and we want the area to the left, so I'm going to shade the left side of this. You do have to know left from right in this class. All right, now we want 0.3 as the first two, so 0.3, and then it ends with a 4. So here's the 4. Now we want to see where do those meet. It's going to be the last one over here, and right there, and here's our answer. And I bet you're wondering, what about like if it ends in 0.5 or 0.6? I just chopped off the chart that we need. This chart does go all the way over, and it goes all the way up to like 3, I think, 3.0. All right, but that gives us that this area for this part of the curve is 0.6331. All right, one more of these. Switch to green. Now we want the area to the right of z equals 0.91. All right, well, I'm going to draw my little curve. I'm going to put the mean here in the middle, 0.91, 0.91 is somewhere over here, and then we want the area to the right of that, so we're going above this time. All right, we start off the same way. We got 0.9. It ends in a 1. So we say, where do those two meet? Well, that looks like right here. But that's the area on the left. So that's 0.8186. And if you can look, that looks like more of the areas over here. So to find this area over here, we do 1 minus 0.8186. All right, and whatever that works out to, that's going to be what our area is. 1 minus 0.8186 on my calculator gives me 0.1814. All right, so this is about 18% over here. All right, so now there's also a way to do this on your calculator, which will probably be the way that you're going to do this most of the time. We're going to a new menu called the distributions menu on the TI-84. TI-83, it's in the same place. The way we get there is we press second, and then we press the vars button. It's near clear. All right, so it's just to the left of clear. We're going to choose number 2, normal CDF. So it's the one with the C, not the P. We're never going to use the one with the P. And then it's going to ask us, what's our lower bound, what's our upper bound, what's our mean, and what's our standard deviation. All right, sometimes this is a little trickier coming up with all the numbers. With the other ones, we just needed the one number, the Z, and then we had to figure out what side we were on. All right, once we put in all those numbers, we're going to select paste or just press enter down at the bottom. And then it's going to bring us back to the home screen, and we're just going to press enter again. If you're using a TI-83 or the Graph and Calc app, Graph and Calc 83, once you choose normal CDF, you're just typing in the numbers in the same order with a comma. So it's going to be mean, comma, standard deviation, comma, lower, comma, upper, comma. I think that's wrong. I think that goes lower. I think this goes in the back. I think lower comes first, upper comes second, and then mean, then standard deviation. Oh well, I don't have one of those calculators in front of me. I'm trying to remember what it is. I don't even have one at school either. All right, so let's take a look at how we do this on the calculator. All right, so we've got our same z-score. So the first thing we would do is we would draw our graph. So back to here, drawing the graph. All right, 0's in the middle, 1.12. And we want to the left again. Should get just about the same answer as we got last time. Bring back our calculator. And vars, here it is right next to clear. So we press second, vars. We want the second one, normal CDF. All right, for the lower bound, we want something very small. All right, we can leave it like that because that's -1 with 99 zeros after it. Or we can just put like -10 in this case, or -100, or -1,000, -10,000, whatever. Our upper is going to be where this stops, 1.12. All right, since we're working with our standard normal curve, you can see here our mean is 0, our standard deviation is 1. So we're going to leave all those the same, and then we're going to press enter on paste, and it brings us back to the home screen, and that's the order. So yeah, that's the order. Sorry guys, with the 83, it's lower, then upper, then mean, then standard deviation. And if we press enter, we get 0.8686, which is the exact same answer we got last time. All right, so our answer here is 0.8686. Now, if you're working on the AP exam and you use your calculator to get this number, you want to write out normal CDF. You want to write lower, whatever number you used for the lower, upper, whatever number you used for that, which was the 1.12, mean, which is 0 in this case, and standard deviation, which is 1. All right, if you're writing it out the other way, like if you were writing it out normal CDF, -1,000 or -10,000 is what we used, 1.1201. If you write it like this, you're not going to get full credit. You have to label what these parts are. So lower, upper, mean, standard deviation. All right, so they've got to be labeled. All right, so we can do the other ones the same way. So this one's going to get the same answer as last time. We'll just bring the calculator back up. All we got to do is go back into vars, second vars, number 2. All right, our lower bound can stay the same. Our upper bound is going to change to 0.34. Our mean stays 0. Our standard deviation stays 1. We press enter. We press enter again. There's our 0.633, and that would round up to 1 just like it was before. All right, if we want to go to the right, well, go back in, we'll do it again. Normal CDF number 2. So that means now our lower is going to be the 0.91. Our upper now is going to be something big because we're going off towards the right. So we'll just put in a big number like 1,000 or 10,000. Our mean and standard deviation do not change. And there's our 0.1814, which I believe is what we got last time too. Yep, there it is. All right, so we can do this all on the calculator, and I recommend doing it that way. Just make sure you write out what you're putting into the calculator so you can get full credit on the free response. If it's multiple choice, knock yourself out. Don't have to write out anything. All right, so here's an example. Find the area under the standard normal distribution left of z equals 2.35. All right, so we are working with z's, so that means we're dealing with a standard normal curve with the mean of 0 and a standard deviation of 1. Make sure we write that. We're going to put 0 in the middle. 2.35 is going to be way up here. And we want left. So we're going to shade in down below it, this side over here. I don't shade in all of it, I just draw my little lines to show that it's colored in. You can shade in as much or little as you want to. All right, now I would either go to my table and look for 2.3 and then 0.05, or I would do normal CDF with a lower of negative, say, 1,000, an upper of 2.35, where our section is going to stop, a mean of 0, standard deviation of 1, and we can just type that in, and our calculator should give us the answer. So let's type that in. So second vars, normal CDF, we've got negative 1,000, or we can put 10,000, it doesn't really matter, 2.35, 0, 1, paste, enter, 0.9906. All right, looks like we got answer choice D. Let's see, is it D? It is D. Good job. All right, so sketch the regions, find the areas. So again, this should be pretty quick for each one. So we want z less than negative 1.45. We're working with z-scores. We're working with the standard normal curve. So we got 0 here. Negative 1.45 will be down here. We want less than, it'll be this section here. Should be pretty small. All right, z greater than 2.13. We'll come back and do the calculator work later here. So here's our normal curve. Here's 0. 2.13 is going to be pretty high up. And we want greater than. So it's going this way, this little bit up here. Pretty small. And lastly, we've got z between two numbers, which looks like more work, but it's actually less work on your calculator. You don't have to think as much. It gives you what two numbers are your bounds. So here's 0. I kind of messed up that normal curve, but you know what? It's okay. Negative 1.56. As long as you don't draw it like this, guys, you're fine. Not like that. That is not a normal curve. That's a strange looking half circle. All right, it curves up at the ends and keeps going forever. All right, it does not even have to touch the axis. Like this one, see, neither one touch the axis. That's perfectly fine. And we want between those, so we're going to color in this section here. All right. And now we just want to find each of those areas. So we just throw it into our calculator. So second distribution. The first one, let's see, normal CDF. We are going down, so negative 1,000 works there. We've got negative 1.45. We just press enter a couple times because we're not changing any of that. And we get 0.0735. There's our answer. 7.35%. All right, let's take a look at the next one. Second vars, number 2, normal CDF. All right, this time we're going up. So we're starting at 2.13 and we're going up to something big like 1,000 or 10,000 or a million, whatever. We get 0.01658. All right, so 0.0165, plenty. All right, don't even have to round. And lastly, now they're giving us both ends. So again, we're doing our normal CDF. So second vars, normal CDF. We've got negative 1.56 as our lower bound. We've got 2.81 as our upper bound. See how this is even easier because they give us both bounds here. We don't have to figure out, are we going down to negative 10,000 or up to positive 1,000, whatever. They give us the numbers. And there it is, 0.938. So this area in here is 0.938 or 93.8% of the data. All right, so here's another one. See if you can work that one out. All right, so you can draw the curve, but what we're going to end up putting in to our normal CDF is our lower bound is negative 1.28. Our upper bound is 1.75. Our mean is 0. Our standard deviation is 1. And we just put that in, and that should give us 0.85. Now, you should have been able to rule out 2 of these. We can't have an area bigger than 1 because the whole area is 1. So those are definitely out right from the start. All right, now I bet you're wondering, are we always going to use this 0 and 1? No, in fact, most of the time we're not. So in the old days, they always had to do 0 and 1 because that's all we had was the table was in terms of 0 and 1. Now, our calculator will do it with any standard deviation and mean that we want. So let's look at these two events here, and then we'll try and do it on the calculator. So a student at a fancy private school scores over 1,500 on the SAT when the school scores are normally distributed with a mean of 1,350 and a standard deviation of 80. Or a student at an inner city school scores over 1,330 when the school scores are normally distributed with a mean of 1,050 and a standard deviation of 125. So which one of these is actually a more impressive feat? Which one is less likely to occur? So if we look at section A here, so event A, we've got a normal distribution. All right, I'm going to go ahead and write it out like this. Normal distribution with a mean of 1,350 and a standard deviation of 80. So here's 1,350. And we want to know what's the probability of a student scoring over 1,500. Now, obviously, this does stop at 1,600, but for the sake of our argument, we'll pretend it just keeps going. All right, option B, we've got another normal distribution. All right, our mean here, though, maybe I should have drawn this a little bit farther over, but our mean here is 1,050. And we want to know what's the probability of scoring over 1,330. So I tried to draw them both so they look similar, so I can't tell from the graph. So remember, for this one, we've got 1,050 and a mean of 1, or a standard deviation of 125. So now what we can do for each one of them is just our normal CDF. All right, for this one, the lower would be 1,500. Our upper would just be something big. I know we can only go up to 1,600, but we're just going to put something big, 10,000. All right, our mean is 1,350. Our standard deviation is 80. For the other guy down here, again, we're going to use normal CDF. For this one, the lower is going to be the 1,330. The upper is going to be, again, something big. The mean is 1,050. And the standard deviation is going to be the 125. And we just want to work out each of those and see what it comes out to. So bring back our calculator. Let's move it over so I can see. So let's see, second vars, normal CDF. Our lower is 1,500 for the first guy. Our upper is something much bigger. So what is that, 100,000? That'll work. And now we can put in our mean, 1,350. And our standard deviation is 80. And we'll press enter a few times until it gives us our answer is 0.0304, I guess is what that would round to. So this area here is 0.0304, or about 3%. Score over 1,500. Now let's try and do the same thing with our other distribution. So back to normal CDF. This time we're going from 1,330 just up to something big. We can leave that. Now our mean is 1,050. So our mean's a little bit lower, but our standard deviation is a little bigger, 125. We get 0.0125. All right, so this one, 0.0125. So this has about a 1% chance of happening. That has about a 3% chance of happening. So the one that's least likely to occur is option B. All right. So comparatively for their school, people scoring over a 1330 are doing better than comparatively to this other school, people scoring over a 1500. All right, last one here, I think. Use the z-score formula or standardize and then use the table or use the calculator. So again, we can just use the calculator here. The distribution of cholesterol levels in 14-year-old boys is roughly normal with a mean of 170 milligrams per deciliter and a standard deviation of 30 milligrams per deciliter. Levels above 240 may require medical attention. What percent of 14-year-old boys have more than 240 in their cholesterol score? So let's see, we've got normal distribution, 170 and 30. We want to know the probability of being above 240. We can draw our curve, 170, 240, and we want to know what that area is. So we're using our normal CDF. Our lower is 270, or no, sorry, 240. That's a 4. Our upper is just going to be something big. Our mean is the 170. That's where the 7 was. And the standard deviation is 30. And we can throw this in. Second vars, number 2. We've got 240. Something big. Something big's already there. 170 for our mean and 30 for our standard deviation gives us 0.0098. So we get 0.0098, which would be 0.98%, or just about 1%. All right, and there's our answer. All right, here's another one if you want. We've got adult men, normally distributed, mean of 69.1 inches, standard deviation of 2.9 inches. What percent of men in the U.S. have heights between 65 and 72? You can stop it and work it out if you want. I'm just going to go ahead and start writing it out because I think I'm going a little bit long on this one. So our lower is going to be 65. Our upper is going to be 72. Our mean is going to be the 69.1. Our standard deviation is the 2.9. We're throwing it into normal CDF, and it should give us a decimal. That decimal is 0.762, so 76.2%. All right, so that's how we can find probabilities or areas using our calculator or the standard normal curve. That's the end of 3.1, so keep an eye out for the Sporkle quiz to get your note grade and the assignment to get your homework grade.